Hi everyone! For today's video, I'm going to show you how to derive the 6 trigonometric functions of angles other than the quadrantal angles from our previous 2 videos. So what angles are we talking about if they're not the quadrantal angles? I'm talking about 2 sets. First is the 30, 60, 90 triangle, and second, the 45, 45, 90 degree triangle. So before we can even go to the part where we can compute for the 6 trigonometric functions, we have to first identify what the opposite, adjacent, and longest sides are of each of these angles. So we already know the values for 90 degrees, but we don't know yet the values for 30, 45, and 60. And that's what we're going to discover today. So I'll start off with 30, 60, 90. So for 30, 60, 90, I will make an equilateral triangle. So let's start with an equilateral triangle. When we say equilateral, the sides are equal and so are the angles. So it's going to be 60 times 3. So 60 here, 60 here, and another 60 here. Remember that 180 degrees is the sum of the angles of a triangle. So if you divide that by 3, you're going to get 60 degrees. Now, how can I derive a 30, 60, 90 degree triangle from this drawing or diagram? It's as simple as drawing a vertical line, and this line should be perpendicular to your base. So pardon my drawing, it's not perfect, but you get the idea. There. So if you split 60 degrees, since this is an equilateral triangle, naturally the two angles that will be formed are 30 degrees and 30 degrees, right? So that's 60 divided by 2. So now you have a 30, 60, 90 triangle, which is this one or the other one. So let's say that I have sides here. I will put x as the length of the side. So if this is x, automatically the other two will also be x, right? Now, if I'm going to extract one of the triangles from this drawing, it's going to be looking like this. So I'm going to extract this first half from my drawing. How will it look like? So it's going to look something like this. You have your 60 degrees, you have your 30, and your 90 degrees. Okay, so we already know from this original diagram that the length of this side here is x. So I'm going to assign the same value here. But how about the other two? How can we derive those? So we can start with the base first. Again, we bisected the topmost vertex into 2. So what will happen to this length here? This will also be going to be half of the original length, or I can simply say that it's x over 2. Now, how can we derive the height here or the other side? Remember the Pythagorean theorem? So we have this formula here, a squared plus b squared is equal to c squared, where a and b are the shorter sides of the triangle and c is the longest, or what we call hypotenuse. So in this case, we have the hypotenuse and one of the sides, we only need to identify the other side, or we call it in a right triangle, one of the legs. So let's assign B as the value of that other leg. Okay, I'm going to label this B. Now we just need to compute, substitute A. So this is going to be our A, and this is going to be our C. A squared is x over 2 squared. Then we have the variable here that's missing. And then C is x. Then you just square it. Then I'm going to keep B on the left side, but I'm going to transfer x over 2 squared to the right. It becomes negative, so that's going to be x squared over 4. Now we want to get the common denominator of this 2, so that's 4. This is 1, so 4 divided by 1. 4 divided by 1 is 4 times x squared, that's 4x squared. Then you have x squared here. Then that's going to be 3x squared divided by 4. I'll continue it here. Our b squared will look something like this. 3x squared over 4. Now how do we get the value of b? You just get the square root of each. So that's going to be square root of 3 times x divided by 2. Or I can simply put here x square root of 3 over 2. So that's the other length of my triangle. So this is how it's going to look. This is your triangle. This is your longer leg, 60, then 30, and then 90. Then we assign here x over 2, x, and the value here that we computed, x square root of 3 over 2. Now I want to simplify this, everyone, so that we can get rid of the denominator. I would call this, or I would assign a ratio to this. So we have the shortest side here, the one opposite 30, then the longer one opposite 60, and this is the longest. So I will write it in that order, from the shortest to the largest or longest. So 30 degrees corresponds to the one opposite it. That's x over 2. Then my 60 degrees corresponds to x square root of 3 over 2. And then finally, the longest side here, opposite 90 degrees, is x. Now how do I get rid of the denominator? I will just multiply all of this by 2. So I will have x is to x square root of 3 is to 2x. So what does this tell us? 30 degrees, 60 degrees, and 90 degrees. So it only tells us that the shortest length, or the one opposite 30, is always half the longest length, or the one opposite 90 degrees. And to get the medium length of the triangle, one of the sides of the triangle, you just multiply the shortest by square root of 3. So that's how it works. I can also simplify this as, if I assign 1 as the value of x, that's going to be 1 is to square root of 3 is to 2. So this is the final sides that I will assign to my 30, 60, 90 triangle. This is how it's now going to look. 60, 30, and 90. Then opposite 60 is the longer leg. Opposite 30 is the shortest. And opposite 90 is the longest. So we already have the sides opposite and adjacent to each angle here, 30 and 60. Now, how am I going to get the values of the 6 trigonometric functions given this length of sides? So let's move here. We can deal with 30 degrees first. So my drawing is going to be like this. I have 30, 60, and 90. So remember, this is 1. This is square root of 3. This is 2. So now I can simply derive the different trigonometric functions for the angle 30 degrees. So let me put it here. Cotangent, secant, and cosecant. So sine is only opposite over hypotenuse. So what is our opposite side? It's this one. The adjacent one is always the leg that touches the angle, one of the sides of the angle, and the hypotenuse is always the longest side. So let's put here opposite, adjacent, hypotenuse. So there, opposite over hypotenuse is equal to 1 over 2. Cosine is adjacent over hypotenuse, or square root of 3 over 2. Tangent, shortcut is sine over cosine, or opposite over adjacent. So opposite is 1, adjacent is square root of 3. Now, you have to simplify this because in some universities or schools, it's not allowed to have a radical as the denominator. So you will have to put it on top. But we're not going to reciprocate, okay? What we will do is we will multiply both numerator and denominator to square root of 3. So that square root of 3 squared, which is this one, the one at the bottom, if you multiply those, you will eliminate the square root, and then you will be left with a square root, but on the numerator, not the denominator. So that's a more valid answer there. Then for the cotangent, that's just the reciprocal of the tangent, so a over o. This is square root of 3 over 1, or square root of 3. Secant is the reciprocal of cosine. So our secant here, let me move it a bit. So what is our secant? Again, it's the reciprocal of our cosine. So cosine is square root of 3 over 2. That's going to be 2 over square root of 3. And again, you have to derive this so that the radical will be removed from the denominator. This is going to be 2 over square root of 3 times square root of 3 over square root of 3, or 2 square root of 3 over 3. There. And then lastly, we have the cosecant. This is just the reciprocal of sine. So 1 divided by 2, the reciprocal will be 2 divided by 1, for 2. So there you have it. You already have the 6 trigonometric functions for 30 degrees. Now, how are we going to get the 6 trigonometric functions for the other angle, 60 degrees? We're going to have the same method here, but of course, our diagram will change a bit because we want to focus on 60 degrees and 90. So this is square root of 3, 1, and 2. So what is your opposite? That's square root of 3. Your adjacent is 1. And your hypotenuse is 2. So you can get sine of 60, that's opposite over hypotenuse, or square root of 3 over 2. Cosine, on the other hand, is just the adjacent side over hypotenuse. So that's just 1/2. For tangent, this is just opposite over adjacent, or square root of 3 over 1. Simply square root of 3. For the cotangent, you just reciprocate the tangent. So that's a over o, or 1 over square root of 3. Then what do we do again? We multiply both sides, or both numerator and denominator, by square root of 3. So that becomes square root of 3 over 3. Secant is reciprocal for cosine. So that's h over a. Hypotenuse is 2. Adjacent is 1. So 2. And lastly, for our cosecant, that's h over o, or 2 over square root of 3. Now what do we do here again? You multiply both by square root of 3. So that becomes 2 square root of 3 over 3. So again, that's it. You already have the 6 trigonometric functions for the angle 60 degrees. Now this is going to be easier, the next set, because 45, 45, 90 is actually an isosceles triangle, meaning you have two sides that have the same length. So how it looks is like this. So 45 and 45, then 90. So if this is 1, then automatically the other length is also 1. Now how to get this longest side here? Again, you apply the Pythagorean theorem. So a squared plus b squared is equal to c squared. And your a here can be interchanged with b. So we don't have any problems as long as both are the legs of the right triangle. So that's 1 squared plus 1 squared is equal to c squared. This is 2. So what is the value of c? Just get the square root of 2. So how our triangle would look is something like this. So if you have 45 here and 45 there, and these are 1, and the longest is square root of 2, then you can just assign the variables for each. So we all know this is already the hypotenuse. Then what's adjacent? If we're focusing on this angle here, the adjacent side will be this one, and this will be its opposite. But for a 45, 45, 90 triangle, it doesn't really matter because they have equal lengths of the shorter side. So we get now the 6 trigonometric functions. We start with sine. So that's opposite over hypotenuse, or 1 over square root of 2. I will multiply both numerator and denominator by square root of 2. So this would look like square root of 2 over 2. Now, since your opposite and adjacent lengths are the same, then your cosine will have the same value as your sine. So it will have the same computation. And your tangent is opposite over adjacent. That's 1 divided by 1, so 1. Then your cotangent will be the same. Reciprocal of 1 is also 1. For the secant, you already know that it should have the same value as your cosecant. So for secant, reciprocal of cosine, that's h over a. So your hypotenuse is square root of 2 divided by 1. So square root of 2. And lastly, your cosecant should have the same value as your secant, which is hypotenuse over opposite, or square root of 2 over 1 again. So there you have it, everyone. We are able to derive the 6 trigonometric functions of our 30, 45, and 60-degree angles. So thank you guys for watching today's video. For our next video, we can discuss the 6 trigonometric functions of the coterminal angles of these 3 angles that we mentioned today. Thank you, everyone. Please like my website and my YouTube page, my TikTok. Subscribe and share to all of your friends, your families, to all those you think need help with mathematics, and I will be more than willing to produce more videos for you. Thank you for watching.